sometimes, right? Sometimes it's nice and easy, right? Where we have, it's nice and easy where we have partial fraction that look like this, right? In a case like this, follow what here, Kidan, follow what here now. When the highest power of x, right? When the highest power of x in the denominator is larger than the highest power of x in the numerator, this is a proper fraction. Okay? Now, it will be improper, right? If the highest power of x on top is more than or equal to. Okay? So this will be improper. So the rules for partial fractions won't work. We have to do something before. And somebody said the answer last week. What would you do to make this proper? What should you do to make it proper? Oh, okay, what to make it mix? To make it mix. What you would do? You would divide, right? All right, yes. Right? So to turn this into this, you long divide. Are you okay with that? Yeah. And after your long divide, you're going to get something that's nice and easy to work with. All right? So head up improper fractions, and I'll give you some examples of how to handle them. Right? A fraction is improper. A fraction is improper. If the highest power of x in the numerator, if the highest power of x in the numerator if the highest power of x in the numerator is greater than or equal to, is greater than or equal to greater than or equal to the highest power of x in the denominator is greater than or equal to the highest power of x in the denominator. Right, that's the first thing you have to look for. Highest power of x in numerator and the highest power of x in denominator. What's up? Right? To fix this, we, number one, long divide, and number two, number one, we long divide, and number two, we then apply partial fractions. Rules to the proper right? We apply partial fractions to the proper part of the answer. Right? Right? Only to the proper part, right? I'll explain to you how to handle this, right? All right. So what's here? Right? So if you look at this example here, right? What's the highest power of x in the numerator? What's the highest power of x here? X squared, right? So that would be 2, right? That's okay. When you multiply it, you'll get x squared plus x. So the highest power of 2. What about here? When you expand this out, you'll get x squared minus 3x plus 2, right? So the highest power of x is 2. Right? So they're equal. So the rule says if the highest power of x is more than or equal to the highest power down here, then we consider it to be improper. That's okay? What do we do now? What do we do now is the long divide. So step number 1, I am going to long divide this into this. That's okay? How are we doing that? What's the first thing I should do? To long divide this into this. So write it like this. Write it like that. Expand it out, right? Expand it out. Let's say write it like that. Right? So when we expand it out, you'll get x squared plus x here. And underneath here, you'll get x squared minus 3x plus 2. You remember how to long divide?
Yeah.
Yeah?
Yeah.
Okay, Shash? So, yeah, go ahead.
For me?
Yeah?
Okay, yeah.
What to do?
X squared is multiple.
X squared to x squared is?
1 and 1 multiplied by x squared is x squared and you minus.
No.
Yeah, that's minus x squared.
Well, no, yet you have to multiply it out. 1 by x squared is x squared. 1 by?
1 minus, yeah.
1 by 2 is?
2.
Now you can minus. The wrong way.
No way.
Right? X squared minus x squared is 0, right? Plus x minus minus, that'll give you 4x minus 2. That's okay? X squared minus x squared is 0. X minus minus 3x is 4x. And then you bring down this. That's okay? Can we long divide again? Can we divide x squared into 4x? No. So therefore, our answer is now this. X by x plus 1 over x minus 1 by x minus 2, which is here, right, Olia? Is equal to what? Is equal to 1 plus this over this. 4x minus 2, I am not going to write it like this, I'm going to write it like this. That's okay? You're okay with that? So now, what do? Apply partial fractions to the proper part. That's okay? So, now we're going to apply partial fractions for x minus 2 over x minus 1, x minus 2. Hey, this girl named Anel. Did you get through? Anel, go ahead. Right? I still take up these denominators here. What are they? They are linear, right? So it will be a over x minus 1, b over x minus 2. Right? They are linear. Right? What to do now? Chana, what to do now? How many other how many other? No, mom. Not yet.
Wait, not yet. I want to have to take it. Jana multiply, wait. Multiply by 1
Right. Multiply everything by this. So you'll get 4x minus 2 is equal to a by x minus 2, b by x minus 1. Right? If I plug in what? We can expand, we can work it out right here. One is 0, one is that 2. I got a to be minus 2. And then when I put 2 there, I'll get that, I'll get that, I'll get 8 minus 2 is 6. And we done. Up, around the space. Just expand it and compare. Right? So the final answer, I'm writing it here because I ran out of space, is 1 minus 2 over x minus 1 plus 6 over x minus 2. Huh? Yeah. When you plug in 1, that becomes 0, that becomes minus 1. Expand it and do you see it from last week? Expand and compare. But this is module 1. Oh, after module 1, I'll do more. Maybe you had a different module and what other.
Yeah.
Right, so the number one thing to do is to check and see if it's improper, right? Right, let's go again. Right, Olia. Just I'm gonna go over this one more time. After your long divide, the whole number comes here, right? And the fraction is your remainder divided by your original quotient here, right? That's okay? So it's 1 here, this over this here. Anybody else gonna minus 2? 1. That's stupid. Yeah, A is minus two and B is. Right, can I take it off and try next one? After this now, the next stage is to integrate. Remember, this will only work if it's an improper, right? How will you know it's improper for Victoria? Suppose you're not too sure and you end up long divided. How you'll know it's improper? This will be bigger than this. So this here will be what? It will can't divide, right? It will can't divide. Right? Express this into partial fraction. Try this, please break it up with the partial fractions, right? I'll walk around and watch you. Any questions online? Obrigado, Maria Firmeza. I've seen some mistakes with long division, huh? I'm going to do long division for you. Right? I'm going to check your long division. I've seen some mistakes with long division.
I told you.
Alright, first thing a problem with the long division. So I've seen a problem with the long division, right? Some people got this. I'll do it. I think I got some people. Right. So I've seen some mistake with long division, right? So watch here. Outside will be x squared plus 2x minus 3. And inside here is x cubed. What you see earlier? One of the reasons you're making a mistake is that you're forgetting that here is 0x squared plus 0x plus 0. So I'm not sure if you remember in add maths, right? When the term is missing, sometimes you just write it with a 0. Right? So you write them in with the coefficients of 0. And then you long divide. Right? X squared into x cubed is x, not 1, right? X by how? What? X cubed over x squared division minus. Right? So x by x squared is x cubed. What you see? I can see the mistake here. X by x squared is x cubed. X by 2x is 2x squared. X by minus 3 is minus 3x. Okay? You all forgot to multiply here as well. Now you're going on minus. X cubed minus X cubed is 0. 0 minus 2 will be minus 2x squared. Minus and a minus a plus. Just so you don't make a mistake, bring down the 0 as well. That's okay? And then long divide again. X squared into minus 2x squared is minus 2. Minus 2 by x squared. Minus 2 by plus 2. Minus 2 by minus 3. Now we're going to minus minus again. This will become 0. This will become 7x minus 6. Right, Yash? I think you had minus 7x, right? You sure?
Yeah.
So x cubed over. So your answer will be x minus 2, right? That will become this value here, plus 7x minus 6 over this. And this here is x minus 1, x plus 3. That okay with that? Now you apply partial. The mirror follow? Right? You'll follow the long division because that's where you made a little mistake, right? Fix the long division and do the partial now. Are you okay online? Chelsea, are you okay? Yeah, next week we have a class, we'll have to do then. What I said, yeah, no? Another one. Yeah, it's yeah. Yeah. So we have class next week, right? What time is that? 11? I saw class a little over 15 minutes. 11 minutes? Okay. 2 hours. 2 hours and 9 months. Yeah. Follow what you can, follow what? Right, then you must write this first and the partial fractions first. Okay? So your final answer will be this plus the partial fractions for this. Darian, paying attention? Darian. Sorry, you're okay. Darian, now log in. Want to log back out. Yeah, look at Darian there. Put a plane today. Oh. Yeah. Okay, how are you going? Right, so when you apply your partial fractions, it will be A over X minus 1, B over X plus 3. Right? And we're above that side there, and we'll try and squeeze the in. Yeah, next week important because I'll do the integration. Kalina, Anelka, y'all getting through? Right? So you multiply it out. I'll do this one in full, right? No mental thing, right? Right? When we compare, it will be A plus B is 7. And 3A minus B is minus 6. A plus B is 7. 3A minus B is minus, right? Add it up now. I got what? 4A? 4A to be 1. A is a quarter. Yeah. And B will be what? 27.14. That kind of leave one. Right. So your final answer is this, right? Your final answer is x cubed. Right? Final answer. I'm writing it here. Your final answer will be x minus 2 plus A. So do write a quarter on top. You could write the 1 on top and bring the 4 underneath. Same thing, right? So you could write your final answer like this. Instead of 1/4, you could bring the 4 underneath. Okay? So your final answer looks like this. Plus 27 over 4 by x plus. That's okay? Copy them. Let's try one more and I'll introduce integration. Huh? I don't want to copy it. You got to copy it. Very good, right? Right, last one before we look at the integration. One more, right? And I'll give you integration after that. All right, take your time. Break it up into partial fractions, please. Break it up into partial fractions, please. Yeah, one minute. Right? There's something have to do with the denominator going into the partial, right? Take a 10 minus partial part, right? Yeah. Right, we will start the easy part of the integration today, right? Again, because that's the angle of how everybody does it, right? No, that's just it. Right, again, a signal mistake to the long division, right? Children has mouth here now. Right. Right, everybody look here now. Look here, right? I want to make sure that I want to make sure we get the long division right. I added in the 0x squared because the x squared term wasn't here, right? X cubed into x to the fourth is x. All right, here, 0x. Sign no really matter. If you have your 0 or whatever. It's still 0, right? X cubed into x to the fourth is x. X by x cubed is x to the fourth. X by minus x squared is minus x cubed. Minus, minus. This becomes 0. This becomes minus 3 plus 1. That'll be minus 2x cubed. And then you bring down the 0x squared. You bring down the 0x and you bring down the minus 3. Bring down everything one time. X cubed into minus 2x cubed is minus 2. Minus 2 by x cubed. Most people have this, but it's this last line here. Minus 2 by x cubed minus 2 by this is plus 2x squared. Right? So now we minus in. This becomes 0. This becomes minus 2x squared. Right? Check back your signs. So people add plus. And then you bring down the minus 3. Okay? So it should be minus here, right? So your final answer is this. X minus 2. Right? And you could write plus minus 2x squared minus 3 all over x cubed minus x squared. Did I ever teach you a cubic denominator? So what should you do? Factor out. So factor out x squared. So you'll get x squared by, right, question. Anybody could answer? Should I use a quadratic here or a repeated linear? Should I use a quadratic here because it's x squared? Or should I use a repeated linear? What you all think? Either could work. Right? If you choose a quadratic, it should work. But the easier thing with terms of values might be repeated linear. Right? Yeah, if you want factor x alone, and you'll get x squared minus x, yeah. But you'll have to use quadratic in there. So it might be a little bit different to how my solution looks, but it should also work. So you'll get minus 2x cubed minus 3. I am doing repeated linear, right? So a over x plus b over x squared plus c over x minus 1. Right? Or you can do a quadratic, right? Okay with that? Sorry again. Ciao, sì. Perché vai a fare le mo. All right. Let's finish up this and I want to do some integration, right? Right, online, we okay? Right, so remember you just continue from last week with the part here, right? Kayla, that looking, Kayla is 3 and 3 or 2 and 3? He is what? What I get for you? 3 and he is also 3. Oh no, something right there. Check it out now. So multiply everything by x squared, x minus 1. So you'll get minus 2x squared, that should be squared, minus 2x squared minus 3a by x minus 1, b by x minus 1, and c by x squared. Right? Because I recognize that they kind of separate out nice. You have different options, right? You can put x as 0. So you'll get minus 3. This will turn this whole thing into 0. This will give you a b by minus 1, and this will become 0. So what that means is I could easily find b at 3. Right? So 3 on x squared. Right? And I know what is b. Now I'm going to put x is 1. So if I put x as 1, I'll get minus 2 minus 3, which is minus 5. This becomes 0, this becomes 0, and I will get c. So c is minus 5. Right? There is no other value I could put. So because I already have b and I have c, I'll choose a random value like 2. So I'll choose x is 2, b is 3, c is minus 5. Okay? This is the second technique. Or you could compare coefficients, right? Anyone could work for. So when I plug in 2, 4, 2 squared is 4 by minus 2 is minus 8, minus 11. By a, 2 by 1 is 2, 2 by 1 is that, so that's 3 by 1 plus minus 5 by 4. So I got minus 11 plus 20 minus 3 is 2a. So I got what, 6? So I got a to be 3 as well. Yeah. That's not right. I'm gonna try this. Yeah, I should just check it back. I think you got 2 somewhere. Oh. Awesome. Yeah. Yeah, you'll get the same answer. No, Dama. So if you treat this as a quadratic, you get the same answer. Okay? If you break up your quadratic, you'll get the same answer. Right? Right. Sorry, Kayla. It was P2 and the wrong thing there. Right. How do we integrate now? Right? So Adelia, the question is going to ask us, Adelia, please integrate this. So what Adelia will do is she will do all of this and then try to integrate this here. So I'm going to show you that now. I'm going to show you how to take that real easy. That's like 2 lines. Real basic. Hey, this bad. Oh yeah, copy that down. Copy that down and head up integration. Right, so it didn't matter if you choose the quadratic as a denominator or this. There's a remainder. Watch. If I divide 5 into 11, and I will get 2 remainder 1. So it will be 2 plus 1/5 is equal to 11 over 5, right? Right? So 1 over this plus this. This over this plus this. Right? Right. So watch this here. When I multiply this by each of these terms, firstly, x by this, the x will cancel. And so you'll get x by x minus 1. See that? Let me write it here for you. You're multiplying this here by this term. The x will cancel. So you'll get that. Then you're multiplying it here. That will cancel. So you'll get out. And then x will cancel and you get x squared. That's okay? So you multiply each one. All right. Last thing is integration. Right? So I want to show you how to integrate. Right? How do we integrate something like this? We just focus on that alone, right? Right, sorry. Right, last thing, Pete, and the rest there, right? So now you can watch it. Right. So jumping into integration, assuming you can do a little bit, right? A little bit. Actually, let me do that. Right. How do we integrate? So if I give you the integral of this, right? I'm not doing all the rules, I'm just doing the ones that I need for now, right? I'll give you like 2 rules, right? How do we integrate again? Add 1 to the power and divide by a new power plus 2. That's okay? What's the integral of A? What's the integral of A? AX, right? AX, right? Nice. What about if I ask you to integrate something like this? If I ask you to integrate AX plus B to the power n. How you do that again? Right, so it will be AX plus B, add 1 to the power, and then divide by the new power and the differential of the Right. Question, Jacob. Actually, Keshav. Keshav, what will happen in integration if this n is -1? So what would happen here? Keep this in mind, we build up to this, right? It's in the video, right? It's all. So Keshav, what will happen here? If I said Keshav, integrate this. Huh? It should be at bottom. No, but if you use this rule here, what will happen? Right? And what will happen? You'll get 0. So you'll end up having to divide by 0, right? And if you divide by 0, you get undefined. So therefore, integration for things like this will not work when n is equal to -1, right? So note that right? It doesn't apply to when n is -1. And I'll show you how to handle that shortly, right? But let's just take a look at this. Can we integrate this? Right, we could come into this one just now. Can we integrate 3 over x squared? Yeah, if you want, yeah. What to do if you want to? One. Huh? What you could do? Right, so you could write it as 3x to the -2. So therefore, when you integrate this, you'll get 3x to the -2 plus 1 over -1 plus 0. So you'll get -3x to the -1 or that. You all okay with that? So therefore, we can integrate this. Everybody okay with that? We can integrate this. But the problem here and here is what? When I bring this up, it becomes to the -1. We can't integrate that. Right? But I want you to run back through in your mind, in there, somewhere there. Somewhere in your mind, I want you to search for this. What do you differentiate to get something like this? Ln, right? Ln. What's the differential of ln 2x? 2 over x, 2 over 2x. Remember that? All right. Well, remember that? Huh? What's the differential of x plus 1? The differential of this, the differential of ln x plus 1 is 1 over x plus 1. Okay? So therefore, the integral of this is this. All right? So we're going to just focus on how to integrate functions like this. Okay? Copy this down. You're okay with this basic integration? And the problem is this, right? When n is -1. Great, you will enjoy this class. All right, copy down, and let's take a look at how to integrate when the power is minimal. But I see what she's working. She's already come and stay quiet for a while. All right, online, we just doing 2 of those and we done. Anybody writing here? Oh, here. Right. That's just go along. That's all. Yeah, finish this by now, right? Right. Jacob. Jacob, what's the differential of 2x minus 3? 2. So if you look at this here, the numerator is the differential of the denominator. And if that happens, the integral of that is ln f of x. So the answer is what? Ln 2x minus 3 plus c. All right. So next week class, well, I wouldn't do anything too new. I would just do plenty of these. Okay. Partial into this. Next one, number 2. No, I'm not done, please. I'm not done. Pete, you just hurry to head up. Do this one from my feet.
Okay.
What's the integral of this? Ln of what? What's the differential of this Pete? 2x minus 1, right? So what to write there? What writing in here? What's the rule now? What's the rule? Right. That's all. When you say that. Oh, I didn't hear that. What do you wouldn't take that, Pete? Right. Last one. Jesse. Think about number 3. Can I use the rule for number 3? No, why? Wow, almost 9 up. Almost 9 up. 4. If I write 4 here, can I do that? Yeah? Same thing, right? Same thing to what I originally had, right? So I could do something like this. Correct? And I can use ln now, right? I can use ln now. So that would be 1/4 ln 4x minus 1 plus. That's it. That's okay? Daniela, you okay with that? Right. Quick question. Anybody remember what I could do with that quarter there? It's ln. I could put it as a south. Right? So you will see that later on when they're making a simplified thing. All right, so that's the way you integrate using ln. So look back at the last partial fractions now, Victoria. Can you integrate that whole thing? Look back at the last partial fractions. Can you integrate all 3 parts? Yeah? Normal integration and 2 ln. You see enough? All right. So next day, what we're going to do, right? Next